So here's my thermometer. First, I tried to make this one, and then we realized that that was gonna be too hard to see. So then we made this one, and basically it's just rubbing alcohol mixed with, we couldn't find our food coloring, so we just put Hawaiian Punch in there, and then we glued a clear straw through the lid of this so you could see the stuff go up and down, and then we filled some bowls with warm water and ice water instead of like a thing full of ice. So I'm just gonna take this thermometer, I'm gonna put it in the warm water. Let's give it a second. Oh, there it is. It's moving up the straw. So basically, it's warming the fluid, and then the fluid's atoms are creating energy, and it's making a bunch of pressure, and it's forcing the liquid up the straw. And then if I take this out, because I don't want it to spill everywhere, I can put it in the ice water. And if you give it a few seconds, it should start cooling the atoms down. They should start vibrating less, and then all the liquid should start to settle because there should be less pressure. So with atoms, if energy gets put into them, they get excited, and then they bump into each other, and they need more space between each other, and it creates pressure, and then that pressure forces the liquid up the straw, since liquid is not compressible. And then when this cold is absorbing a bunch of the energy, the atoms need less and less room, and they start to release pressure, and the liquid starts to go down the straw. But it takes a little bit for it to get cooler. It takes longer for it to cool than it does for it to get warm.
It's dropping, it's just slow.
It is really slow. Though, if it wasn't in there, it would take a lot longer. Could you imagine sitting here for an hour because we didn't have ice? See, it's dropping. Eventually, it'll like start moving a lot quicker.
Because the colder it is, the faster it gets colder, right?
That's basically the same thing with the heat, but the heat, it's so much easier to warm something up than it is to cool it down. I mean, you probably wouldn't believe that if you ever get cold before bed. You're pretty warm, and you go in your bed and you get cold. But it's because the atoms already have energy, and then you're just giving them more. You're just splitting it. But when it's cold, it takes longer to give the energy away.
Object in motion stays in motion, right?
Yeah, so it has more electricity, so it's going to take longer to get rid of it than giving something that already has electricity more electricity.
Everything's shaking.
So it's the same with this. If it has a bunch of energy, it's going to take longer to remove it than to just give it more energy.
Should we add some of our ice cubes?
Yeah.
Whoops. It's dropping fast now.
Yeah, it's dropping faster now because we just added more ice so that it would get more of the liquid cold. But yeah, it's already cold, so it's getting colder quicker. We should have got fans and just like started blowing the fans on it too.
You're going up?
Oh, Dad just turned off the air conditioner. That's really cool.
So it was blowing air out.
It was blowing cold air down, so if the AC wasn't on, that would have taken a lot longer.
Yeah, that's crazy that it's rising.
Well, I think that's why they told us to use rubbing alcohol.